Hello everyone. So in this video, let us see the program number 136 from leetcode platform. So that is a single number, so which is from easy level. So this is from actually bit manipulation. Same thing you can found. So if you click on topics, okay. So first of all, let us see the problem statement. Afterwards, example explanation. Next of all, finally implementation. Okay. So, given a non-empty array of integers, so-called nums, next, every element appears twice except so for one. All numbers are repeating for so two times except one number means so that particular number is repeating for only one time. So we need to find that single one here means finding the odd one out. Okay. And observe this, you must implement solution with linear runtime complexity. So means nothing but order of n here and use only constant extra pace means extra arrays are allowed here. Okay. Next, so here some examples are given. You can check. So two is repeating for two times. One is repeating for only once. Here, so one and two are repeating for twice. Four is repeating only once. Okay. Whereas you can see the examples here. And next, observe the constraints. So the length of array. So lies in between 1 to 3 into 10 power 4. Okay. So in this program, I'll explain. So based on constraints, I will get the TLA error, all this. Okay. So how we can resolve that? Let us see then. Okay. Next, so here you can so check the hint. So think about the exclusive or properties operator. Okay. So let us see this one later. Okay. Afterwards, try to resolve the so similar questions. First of all, so brute force solution so strikes into our mind, right? Okay. So let us see that part here. Okay. Let us take one example called so 4 2 1 and so 1 2 something so this array is given, right? Okay, so what is the brute force solution here? Okay, means so counting, let us take so this one 4 at the middle here. Next, so counting how many times so each and every value is repeating here. Okay, so that is so let us take so for 2. Okay, initially so we need to take count of so 2 as 0, and so comparing count of so 2 with all values in array. Okay, so for fixing some so position value and loop is required, and for so traversing so another loop is required. Okay, so here on comparing, so I and j position values. Initially, I and j both are same, right? So count increments to one. Next of all, so now I and j position values, so two and one not matching. Next, so j we update to the four. Again, it's not matching. So j we update to the one. Again, not matching. So now it's matching. Finally, count becomes two. After completion of the J loop, we should check whether count reaches to 2 or not. If it reaches to 1 means we should go for returning it. Okay, so I hope you understood. After that, so taking I to this position and so again starting, so J from the beginning position. So I and J position value is not matching. So again it's matching. Each and every time, so count should start so from 0. So now it's matching I and J positions. So I and J not matching. Now it's matching. Again, count reaches to the so 2 here. Okay. Again, so what you need to do? Again, we need to start so the count from 0. Let us move on to the next position. Again, so J loop starts from the beginning position here. Now I and J not matching. J updates to the next location. Again, so not matching. After that, on updating, so J to the next position, count reaches to 1. So, but in the next positions, you cannot find the 4 here. Count remains 1. In that scenario, should go for returning that position value that is 4. This is brute force solution. Let us see the implementation so part of this one. So observe. First, I am collecting so the length of so array here. Observe the so coding screen here. Already some method is given to that array values are passed here. Array is passed. We need to return integer value. So from the method here, and so let us take so the two loops here for I in range of so n. And each and every time what I said count we need to start from zero, right? Okay. And next of all, so J loop also I'm running for n times. So I'm checking whether nums of I and j position values are matching or not. Okay, if matches, so simply I'm incrementing count by one. After completion of the for loop of j, I'm checking whether count reaches to so one or not. If reaches to one, we need to return that particular position value from the okay. So this is the brute force solution. It is order of n square time complexity. So outer loop runs for n times and inner loop runs for n times. Okay, it's n square. I'm not explaining in detail, so I'm giving you a shortcut. In some other videos, I'll explain. Okay, how to calculate the time complexity. You can gone through in that. Okay. So next, let us run and so text now. Okay. So check everyone. Base test case passed and let us submit now. Observe everyone. Check how much time it's taking to run the program. See, finally got time limit exceeded error. How many test cases executed here? Out of 61, 60 passed. So why that test case failed? Okay, what is the reason behind it? I'll explain now in detail. So first, so observe this, everyone. So to our program, this time limit was fixed, 1 second. Only within 1 second, our program has to be executed. It should not take more than that, okay? And so our computer can max execute 10 power 8 instructions within a second, okay? So now, if you take so the length of an array here, okay? So it lies in between 1 to 3 to the 3 to 10 power 4, right? Okay. So what is the time complexity of our program now n square, right? So means if you take so n value as 10 power 4, okay? So what happens? So 10 power 4 power 2, it's 10 power 8, right? Okay. It's fine. It executes up to the length 10 power 4. So but what if for 2 into 10 power 4 and for 3 into 10 power 4? Definitely exceeds 10 power 8, right? Okay. So within 1 second, it can execute 10 power 8 instructions, but it cannot execute 2 into 10 power 4, 3 into 10 power 4 length arrays here. Okay. So that's why for that test case, it failed here. Okay. I hope so you clearly understood. Now, so let us move on to the so better approach. Okay, so that is with the exclusive or operator, it's possible to so design the program within order of n time complexity. Okay, so let us see that part now. Okay, so for exclusive or we have one shortcut. Okay, if inputs are same, then result is zero for exclusive or, right? Okay, so here for same values, you'll get the result zero. Okay. So this is the truth table of exclusive or A exclusive of B. 0, 0 it's 0, 0, 1 it's 1, and 1, 0 it's 1, 1, 1 is 0. If inputs are same, then result is 0 for exclusive or. Based on this, you can directly consider like this. It's not required to take binary form. Although if you take the binary form also you'll get the same result. One exclusive of 1 is 0, two exclusive of 2 is 0, okay? And so with that updated result, what is the leftover value here? It's 4, okay? 0 exclusive of 4. So 0 means all positions sets to 0. So in 4, whatever the positions sets to 1, you'll get it as it is, okay? So 0 non-zero value exclusive operation gives non-zero result, okay? So this is what we require here. Okay. I hope so you got one doubt now. So I'm not taking so the values in sequence now. Although if you take values in sequence also, you'll get the same thing. Okay. So you can check here. So first, let us apply exclusive OR operation with 0. 0 exclusive OR of 4 is 4 and 4 exclusive OR of 1 is so 4 means 4 position bit sets to 1. 1 means first position bit sets to 1. If different position bit sets to 1, you'll get the addition of inputs result for exclusive OR 5. So 5 exclusive OR of next position value it's 2. 5 means it's 4 plus 1, 2 means 2. Different position bits once again it's 7. 7 exclusive OR of it's 2. So what is common here? So 7 means 4 plus 2 plus 1 and 2 means second position bit sets to 1. 2 is common, that position becomes 0. So in 7 what is remaining here? 5. And so finally 5 exclusive OR of 1. What is common? 1 is common. What is the leftover value? 4. In this way also you can check that you'll get the same result. Okay. That's it. With the help of single expression, we can design the logic now. Where the code length is going to be reduced, time complexity, everything is going to be reduced. Let us see that implementation part now. Initially, I'm taking result storing variable value to 0 and I'm generating so the or else let us take for each loop. I'm retrieving each and every element from the so array here and next simply I'm applying so the exclusive operation with the elements, whatever I'm getting. So finally I'm returning so that updated result here. Now let us check much time it takes. Okay, as best test case first executed. Next, let us submit. See, check now how much time it's taking. It's just 3 milliseconds. Okay, all test cases executed here. So I hope you understood. If you want to pick odd one out, so you can make use of this exclusive or operator. Okay. So time complexity of this solution is so order of n linear. We reduce it from order of n squared to n. Okay. So that is brute force method. First one is, and the second one is bit manipulation method. Okay. I hope so. Each and everyone understood this. Okay. So thank you. Thank you, everyone.